Hi everybody, today's lesson is 1.6, Solving Types of Equations. This is not the first page of your packet. You're going to have to flip through to the first section of 1.6. We're actually going to do those word problems in class together tomorrow. So 1.6 is the video for tonight. And I'm going to go through these 5 examples, and there are some step-by-step instructions you need to follow. First of all, and most importantly, factoring all the denominators if possible. If you look at example 1, you can't factor anything, it's already factored completely, but in example 2 you can factor this. So that's always first thing to do, is factor, so that you can figure out what the LCD is. And then we're going to clear fractions here in these. That's definitely the easiest way to handle these fraction problems. We want to clear them. So that's what we've been kind of practicing a little bit the last chapter. Then we're going to solve, and then another really important thing is to beware of extraneous solutions. Sometimes when you clear fractions, this introduces answers that actually make our denominator equal to 0. But you know that denominators can't equal 0, so in that case you have to cross out that solution. We'll talk about that once we get to it, okay? So very first example here, actually what I'm going to do first is write this and spread it out a little bit so I have a little bit more room to work. So there's nothing that can be factored here, it's already factored, but what we're trying to do here is clear fractions. So look at the denominator of the entire problem. This one has an x minus 3, this one has an x minus 3, and this is basically just over 1. So our LCD is going to be x minus 3. So the goal here is to multiply every single fraction by x minus 3. So I'm actually going to write it next to every single fraction, because whatever you do to one thing in the equation, you have to do to everything. And then what I'm going to do is, before I start foiling, distributing and stuff, is look at a bunch of stuff that cancels. The whole reason I multiplied this by x minus 3 is to cancel that, and I just have x. And then on this side, same thing. This x minus 3 cancels that, and I just have 3. But in this case, nothing cancels, so I need to actually distribute my 3 there. So I end up with 3x minus 9. And then you guys, this is a really simple equation to solve. So we turned this thing that had a bunch of fractions in it into something very, very simple. Okay, so I'm just going to combine my like terms. I'm going to minus my 3x over. That gives me negative 2x. When I combine my 3 and my negative 9, I get negative 6. That gives me an answer of x equals 3. Okay, so now let's think about, remember what I said about the extraneous solutions? When you check your answer, so you have to check, and so what this means is, what we're doing is we're taking our 3 and we're plugging it in. And look what happens when I plug that 3 in right there, or right there. Doesn't that give me a 0 in the denominator? That means that even though algebraically I got an answer of 3, that's an extraneous solution. So my final answer is no solution, because the 3 makes the denominator equal to 0. Remember, the symbol for no solution is a 0 with a slash through it. So that's kind of the last thing that you have to do for this one. It does seem like a lot of work to go through and find the answer, do all the algebra, and then it ends up not working. That means that there is no solution to this problem. Okay, let's try the second one. Remember what I said about this bottom one is that this part factors into x minus 2 and x plus 2. So what I'm going to do here is remember that our LCD is going to be the combination for the entire fraction, or the entire equation. So my LCD is x minus 2 and x plus 2. So the goal here is to clear all the fractions. These are different from what we did in the last chapter because these have an equal sign. When you have an equation, you're allowed to multiply stuff on both sides in order to make it easier to solve. So what I'm going to do is actually write my LCD kind of next to each part of the fraction. I'm going to write, actually I think I'm going to pause this real quick and rewrite this problem so I have a little bit more room. Alright, so I've kind of spread it out so I have more room to write. What I'm going to do is multiply every single fraction by my LCD, which is up here. It's x minus 2 and x plus 2. So I'm going to write that here, x minus 2, x plus 2, write it here, x minus 2, x plus 2, and write it here, x minus 2, x plus 2. There's the bell. Alright, so I've written my LCD next to each fraction, and then again, remember, before you start foiling and distributing and stuff, let's see what cancels. X minus 2's are gone here, so we're just left with 3x plus 2. Yes, I'll distribute that in a second. X plus 2's are gone here, so we're just left with 1 times x minus 2. And then on this side, the x minus 2's are gone, and the x plus 2's are gone, so I just have 12. And now look at this equation. Super simple to solve for x, right? We have no more denominators. That's the whole thing. We hate fractions, you guys. So when there's an equation, again, the key here is that there's an equal sign. When there's an equation, clear the fractions. Cancel them. Let me distribute my 3 here. Get 3x plus 6, x minus 2, and 12. Combine like terms. And then just solve, and we're home free after that. End up with x equals 2. Now remember, the last thing that we have to do is check this solution. So again, I'm going to write check here. When I take this 2, and I'm checking the denominators to make sure it doesn't make any denominators equal to 0. When I plug it in right there, I get a 0 in the denominator. There's the bell again. When I plug it in right here, I get another 0 in the denominator. So anywhere, if it ever happens and you have a 0 in the denominator, you can't use it. Therefore, x, again, is not a valid solution. Here we have no solution again. Okay, so I know it seems, again, it's going to happen a lot. There's a lot of extraneous solutions when you solve these types of equations. This means there is no value for x that makes this equation true. Okay, and it doesn't always happen, but sometimes it does, so just kind of, you got to beware and you got to watch out for those. Example 3, I see a GCF, a little bit of factoring that can be done here, so we always want to do that if possible. And this is going to tell me what my LCD is going to be. So here my LCD, for this entire equation, I need an x, and I also need an x plus 1. So that's what I'm going to do to every single part of this equation, and then I'm going to cancel everything that I can, and I'm going to spread this out so I have a little bit more room to write here. Alright, so remembering my LCD was x and x plus 1. I'm going to multiply this by x and x plus 1. This gets x and x plus 1, and this gets x and x plus 1. And a lot of you might get to the point where you can see what's going to happen and you don't need to do all this writing, and that's fine, but it's very important that you understand that you're allowed to cancel stuff before you distribute. I'm going to distribute my x now. I'm left with 4x squared plus 3x here. And again, no denominator. That is the whole purpose. We want to get rid of those fractions as fast as possible. Here, this x and this x cancel. And I'm going to distribute my 2 as well. So I'm going to get plus 2x plus 2. And then on this side, my x is gone, and my x plus 1 is gone. So I just have equals 1 on this side. So this is a quadratic, you guys, and by quadratic I'm using that vocab word because I have an x squared in my equation. So I'm going to need everything to come over on one side so that my equation equals 0, and I'm going to combine all my like terms. So I have 4x squared, 5x, and when I minus the 1 from both sides I get positive 1. This is going to factor, or I could do quadratic formula, or I could do completing the square, even though completing the square would be really hard for this. I think this factors, if I remember correctly. Plus 1 plus 1. So here we have, foil this in my head real quick, make sure we factored it right. Looks good. So when I equal both of these answers to 0, this answer gives me negative 1/4, and this answer gives me negative 1. So those are my two answers. And now what I'm going to do is check both of them. And all I'm doing is checking the denominator. And so go back up to the original question. You zoom out a little bit. And here I am with my checking again. Check. And I have to check both of them. So this negative 1, when I plug it in here, makes a 0 denominator. It also happens right here. That means I'm not going to use that one. What about when I do the negative 1/4? Only thing I'm doing is checking the denominators just to make sure that it doesn't make any denominators 0. That means my only answer here is negative 1/4. Because this one was extraneous. Therefore, it didn't work, okay? So extraneous is kind of a vocab word. You need to be able to recognize that, but that's what you're looking for in this problem, is that one of the answers worked, one of them didn't. Okay, so we're starting to get some actual answers as we're doing these. All right, let's try example number 4. This one kind of looks a little similar to some that we've done in the past, just because the denominators are a little bit more simple. None of them factor, but I do know that my LCD is going to be x squared. That would be the easiest thing that I could make all of the denominators be the same. That's what we talked about last chapter. So what I'm going to do, I think I can squeeze it all in here, is just multiply every single thing by x squared. This gets x squared, this gets x squared, and this gets x squared. Okay, so before we start multiplying and stuff, you want to simplify and cancel whatever you can. This cancels the x squared altogether, and we just get 7. On this one, the x cancels with the squared, so we just end up with 1x on top with the 19. And in this case, nothing cancels, so I just have equals 6x squared. And again, this is a quadratic, so what I need to do is make sure that everything equals 0, so move everything over to one side so that I can factor it. That means 19x and negative 7. And what I'm going to do here is factor it, equaling it to 0. So in this case, it's a little bit harder to factor. I think I'm going to start with 3x and 2x. And for 7, the only factors are 7 and 1, so I think I'll put 7 and 1. And if I do a negative 21, this is negative 21, then I need a positive 2 here to make 19. I think I got it factored on the very first try. That means I have two answers, negative 1/3 and positive 7 over 2. Now what I have to do, last but not least, is check them. And all I'm checking for is to make sure the denominators don't equal 0 when I plug any of those in. So look at my original problem. They're just x's. So as long as I didn't get an answer of x equals 0, then I'm good. When I plug 1/3 into here or here, it doesn't make it 0. And when I plug 7/2 into here or here, also doesn't make it 0. So both of those answers work. I actually have two solutions in this case. All right, very last one. This one's supposed to be an easy one too. See how it's only two fractions? So here's a little special note I'm going to write on this one. When it's just a fraction equals a fraction. Any thoughts on how to solve this one? When it's a fraction equals a fraction, there's a real easy way to do this. All you have to do is cross multiply. So if you look at like the other 4 examples that we did, it was never just a fraction equaling a fraction. When it's in this form, this is supposed to be a really easy one. You cross this way, keep the equal sign in the middle, cross this way, and then you just solve. Okay, so when I cross this way, I get 2x times x minus 1. Keep the equal sign in the middle, and then when you cross this way, you'll get 3 and x plus 4. So again, no more fractions. All you do is cross multiply. This is supposed to be a really easy one. I don't want you to get lost with the harder stuff that we did at the beginning, because this is something that you should already recognize how to do. So distribute here, distribute the 3. This is again a quadratic. Whenever we have an x squared in our equation, we need to move everything to one side so it equals 0 so we can factor it. That's going to make it 2x squared. Will that be minus 5x and then minus 12? There is no GCF or anything that we can divide everything by to make this a little bit easier, so I'm just going to try and factor it right away. 2x and x. 12 can be written as 3 and 4. So if I make it a negative 8 and then a positive 3, that would make mine negative 5. So now it's a little glimpse into my head as far as how I'm figuring out how to factor these. There's a bunch of different ways to factor those trinomials, as you know. Get it factored, make sure you do it correctly. This means that we have two different answers, negative 3 over 2 and 4. So these are my two answers for x. Last thing I'm going to do is check real quick and make sure it doesn't make any of my denominators equal to 0. So when I plug in the negative 3/2 to this denominator, that doesn't make it 0, it makes it negative 3. That's fine. When I plug in 4 to this denominator, it makes it 8. That's not 0, so they're both good. So these both work. We have two solutions for this one. So you guys, the checking of the answers is the most important part. As you can see in all the notes that we did, we did examples where, this is a little crooked, where we have no solution. And then we have another example where, again, we had no solution. And then we got a little bit luckier and we actually got one solution, but one of them didn't work. And then our last two examples, we actually got all the solutions to work. This one and this one. Both of our solutions work. So just be careful about that when you're doing your homework and when you're checking your work on quizzes and tests. There's no really rhyme or reason to how many answers work and how many of them don't and when does that happen. You just have to be diligent and check every time. That's all we got, you guys. Bring your questions to class tomorrow and get ready for our new chapter, all right? You're doing awesome. Keep it up.